Hi guys, welcome back to the channel. So today we are going to be discussing about the lead code question, which is merge in between the linked list. So we are given two linked list, which is list 1, and then we are given one more linked list, which is list 2, and then those will be having the sizes of n and then m, and then we need to remove the list 1 nodes from 8th node to bth node, and then put the list 2 in their place. Suppose let us think like this is the first linked list, which will have all the nodes which are present in the list one, and then we are also given list two, which is the linked list two. It will contain all the nodes which are present in the list two. Now we need to remove this part from 8th node to bth node from the list one, and then we should keep list two in that particular page, and then at last we need to return this particular head. Suppose let us take this example where we have, suppose let's take this example. We have two things here. This is uh, this is the list one, and then this is list two. Now we are given that we should remove from 3 to 4. That means this will be 0, this will be 1, and then this will be 2, and then this will be 3, and then this will be 4, and then this will be 5. So now we need to remove the nodes from 3 to 4. That means we'll traverse the linked list from here, and then we'll move till here, and then at this place we are going to remove this particular list, and then we are going to insert, in place of this we are going to insert this list 2, and then this linked list becomes like this. So to this will be the linked list we need to return after the operation is done. This is the linked list we need to return. So we just remove this part so that we'll get the this particular result. So how can we solve this particular uh, question? So we'll take the node where we'll traverse each node, and then we'll check whether this particular node is equal to a, and then whether this is equal to b. Now let us think that I have node here, which is n. This will be the node. Now I came here. Now I need to remove this particular case. If I need to remove this particular one, I need to know the previous node, so that I'll match previous next to, instead of this one, I'll match previous next to this particular list 2. And then one more thing is, suppose when I come to B, this will be B. Now when I want to remove this total part, and then I need to get the all the linked lists which are present after B. That means I need to know the next node to B, next node to B. So when I want to remove A and then B, I need to know the previous node to A, and then next node to B, such that I'll match the previous node of A to the next to list 2 head, and then I'll traverse all the nodes which are present in the linked list 2, and then when the list 2 next becomes null, this is not list 2 null, this is list 2 next becomes null, list 2 doesn't become null, then I am going to say I'm going to traverse this particular list, and then whenever this becomes null, this will be null. So at this particular case I am going to stop at this particular node, and then in this node I am going to say the next node of next becomes the next node which is present in the B, and then I am going to return the answer. So for this particular case I am going to traverse all the nodes which are present in the list 1 and then list 2. So it is going to take the time complexity of m plus n, and then I am not taking any extra space for this, like creating new nodes and traversing other nodes. So the the space complexity is going to be big O of 1. So let us see the implementation of the code. So now I know now I need, whenever I have a list 1, I need the previous node to A and then next node to B, such that I'll have the nodes which are previous to A, so that I'll map previous node to A to next element which is present in the list 2, and then after traversing list 2, I'm going to say that list 2 next becomes this particular next node to B. Now I am going to take the node as list 1, and then I am going to count the counter, so that I'll get to know where is the A and then B. Now whenever there is a count is less than A, that means I am going to keep track of the previous node which is present to A. Suppose let's say this is 0, 1 and then 2 which is less than 3. That means I'll store the previous node which is to A, and then whenever this becomes A equal to 3, then I'll not traverse A previous of A to here. Why? Because this will be the previous node to A, and then whenever we get to B, that is count double equal to B, then I am going to store the next node which is present to B. So so if it is less than A, I am going to store the previous node to A as ND, and then whenever the count becomes B, then the next node to B becomes a node to next. Now I am going to increase the count, and then I am going to traverse each node. Now I have two pointers which is previous node to A and then the next node to B. So now, so for this particular case, when we have the two previous node and then next node, we are going to store that previous node and then next node, and then we need to map this particular previous node. So I have previous node and then I have next node. Now we have this particular part, and then we need to remove this part. That means I am going to say previous of next becomes list 2, and then I'll traverse all the nodes which are present in the list, and then I am going to say the next node will be this next to B. So that we are going to see. So I'm going to say previous node to A next will be list 2, and then I am picking the node as list 2, and then I am going to traverse till node next not equal to null, and then node will be traversed from node to node next, and then whenever this becomes null, node next becomes null, that means I need to set the pointer node of next to next node to B, and then at last I am going to return the list 1. And one more thing is, suppose it is given that A will be from 1 to list 1 dot length minus 1. So if we say A equal to 0, that means we need to remove the head itself. That means this will be removed. So for that particular case, we will be considering one more node where it will store the answer. Like, we'll keep this as our answer, and then we'll say answer next will be list 1, and then at last we are going to return this particular answer which is answer next. So whenever let's say this is the node which I want to remove, and then it is mapped to this, so I cannot return the list 1. Why? Because this will be pointing to this node. So for that particular case, whenever I have answer which will have 0 value, and then next will be this one. So for that particular case, the previous node to A will be this one, and then this next will be matched to here, and then we'll traverse like this, and then we are going to say this becomes this. And then when I want to return the node which is our answer, I am going to return not answer, I am going to return the answer dot next, which will be starting from here. So whenever it can be 0, then we are going to consider one more node where we will say that answer next becomes this particular list one. So we cannot return this one. Why? Because this might be removed, so that we'll take this pointer. So for this particular case, the time and space complexity is going to be time is going to be big of m plus n, and then space is going to be big of 1. Yeah, that's all for this video. Thanks for watching the video.